Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this particular video, we're going to solve one question where we have to find the first derivative and second derivative using implicit differentiation. Let's start. The question that we're looking at is this one, x cubed over y minus x is equal to 6, and we are looking for the first and the second derivatives. This is a relation, okay? Y is implicitly defined. And if you haven't seen my earlier video on implicit differentiation, on product rule, on quotient rule, I'd suggest that you go ahead and first take a look at those videos, because in this particular video we might just tend to assume all of that. This is like once you've known your algebra well enough and you know all those rules, product rule, quotient rule, and implicit differentiation and chain rule, then you should be able to do the questions like these where you're required to find the first and the second derivative. Okay, so we're going to first copy down the question as it is: x cubed over y minus x is equal to a 6. Okay, so that's the question. And now the first thing to write is differentiating with respect to x. Remember, we are asked to find the first and the second derivatives. Basically looking for dy by dx and d2y by dx squared. Okay, so it's differentiating with respect to x. What happens is the first term is x cubed over y. That's a quotient there. The second term is just x by itself. And on the right hand side, we've just got a constant. So that's going to be 0. All right. So using the quotient rule for the first term, we should get 3x squared, which is the derivative of the numerator, times y minus x cubed remains as it is. The derivative of the denominator is dy over dx. The whole thing divided by y squared. This is the derivative of the first term, just this first term, quotient rule. All right, so I'm just going to put that in a bracket here, minus the derivative of the next term, derivative of x with respect to x, is just going to be 1. And on the right hand side, we're going to get 0. Cool. Let's just simplify this. What will you get? We'll get this as 3x squared times y minus x cubed dy over dx. Equal to 1 on the right hand side, and that multiplied by the denominator will give you y squared. Okay, so the 1 goes to the right hand side first, and then you multiply this y squared on the denominator with that 1 on the right hand side. You should get this expression then. Now let's just isolate dy by dx. This will be negative x cubed dy over dx is equal to y squared minus 3x squared y. Right, and then dividing by a negative x cubed, you should get dy over dx as 3x squared y minus a y squared, the whole thing divided by x cubed. This is going to be the first derivative. Okay, let's just check our work quickly. All right, so we know that the first term is where we've had this, a slight difficulty, if you were to call it even a difficulty, okay? But it's a quotient rule that we've used there. 3x squared times y, the denominator remains as it is when you're finding the derivative of the numerator, minus the numerator remaining as it is when you're finding the derivative of the denominator, okay? The derivative of y is dy by dx, all right? Divided by, the whole thing divided by the denominator square, the square of the denominator, minus 1 because the derivative of x with respect to x is 1, and the right hand side is going to be 0 because the derivative of a constant is 0, all right? And then when you simplify this, you're basically taking the 1 on the right hand side and then you're multiplying by that y square. Okay, that's algebra. The first step is the differentiation rule. Then it comes to algebra, and as you see the importance of knowing your algebra well, how to, because some questions you'll be asked to bring the derivative in some form. Okay, that's where I think your algebra skills will be tested to the core. So this is the first derivative. Now we're going to go ahead and differentiate it again with respect to x to find the second derivative. Okay, as you can clearly see, this is another quotient. Okay, but it's a very intricate quotient now because the numerator is made up of a group of terms with y's, and there's a product here in this first term of the numerator, and the denominator is a simpler one, but the numerator is slightly different. So in order to differentiate this expression, first let's write down those golden words: differentiating with respect to x. Okay, you're differentiating that with respect to x on both sides. So on the left hand side, when you differentiate with respect to x, that is just the second derivative, okay, d2y over dx squared. On the right hand side is where you're going to have this quotient rule. But before we put the entire term here, let's do our rough work here on the right hand side, okay, to identify the u and the v, the numerator and the denominator. The u is going to be the numerator, which is 3x square y minus y square. It's y square, sorry. That's y square. And when we differentiate the numerator with respect to x, du by dx, the first term is a product. I'm going to go ahead and do it directly, and this is what would be expected from you after you've had enough practice with algebra and all the rules. So if in case you're not able to understand it in the first go, feel free to pause the video, rewind it, and watch it at your own pace, okay? But I'm going to go ahead and do it directly, and this is what would also be expected from you, okay, before you come to the time of your exams. So the derivative of 3x squared y with respect to x would be 6x times y plus 3x squared times dy over dx. That's just the derivative of the first term, by the way, and the derivative of the second term would be 2y dy over dx. Okay, so that first term, because it's a product, okay, 3x squared y, so you've got 6x times y, 6x being the derivative of x squared with respect to x, y remains as it is, plus 3x squared, the first term remains as it is, times the derivative of y, which is dy by dx, minus the derivative of y squared, which is 2y times dy by dx. Okay, that's the derivative of the numerator. Let's write down the derivative of the denominator. The denominator v is x cubed, then dv by dx is going to be 3x squared. That's easier. Okay, now let's put it all together, okay, because it's a quotient, and the quotient rule tells us it's the derivative of the numerator times the denominator remaining as it is. Okay, so maybe I need more space, so I'm going to write it down here. Okay, so d2y over dx squared would be equal to the derivative of the numerator. There's that expression out there. Okay, so let's just write it as it is first. So it's 6xy plus 3x squared times dy over dx minus 2y dy by dx. This is the derivative of the numerator times denominator as it is. That means you're multiplying it by x cubed. Okay, minus the derivative of the denominator, which is 3x squared, times the numerator remaining as it is. That's 3x squared y minus y squared. So that's 3x squared y minus y squared. Just be careful with every step. Okay, the algebra is equally important as you're using the rule. Okay, this is just the numerator. Now you have to write down the whole thing divided by v squared. Okay, so v was x cubed. So I'm going to write it as x cubed, the whole square. Okay, so let's go over this rule again. This is the quotient rule. Derivative of the numerator, we wrote it down here, remember? That's why it's a good habit to do it separately in the rough, but show you're working clearly, right? So identifying the numerator and the denominator, the derivative of the numerator is 6xy plus 3x squared divided by dx minus 2y divided by dx times the denominator, which is x cubed, then the derivative of the denominator, which is 3x squared, times the numerator as it is 3x squared y minus y squared, the whole thing divided by the square of the denominator. Now it is algebra, so be very careful, okay, how you are reducing from here. So I'm just going to go ahead and do that. The numerator is going to be 6xy. We'll multiply with this x cubed, right? So it's going to be 6x to the power of 4y plus 3x to the power of 5 dy over dx minus 2x cubed y. You're multiplying by this x cubed throughout, okay? 6x to the power of 4y, 3x to the power of 5 dy by dx minus 2x cubed y dy by dx again. And then this term, when you multiply by 3x squared, you'd get 3 and 3 is 9, x to the power of 4y plus a 3x squared y squared. And the whole thing is to be divided by, this is x to the power of 6. Okay, x cubed, the square of that is x to the power of 6. Now, what can we do? What we'll do is that we'll group the dy by dx first, because we have an expression for dy by the dx, okay? That expression can be substituted. So let's just group that term. We'd get 3x to the power of 5 minus 2x cubed y dy. Okay, that's dy over dx, right? And then what do we have here? Does any term get cancelled off or reduced? We've got 6x to the power of 4y minus 9x to the power of 4y. So that would just be minus 3x to the power of 4y plus 3x squared y squared. The whole thing divided by x to the power of 6. I'm sure some factors of x to the power of 6 will also get cancelled off. The reason I did this is because dy by dx has an expression here. We already found dy by dx. We're going to put that expression down there, okay? So be careful how you can copying this down. Can you see algebraically it's so intense, right? Okay, so that's why I go slow initially. And so I have 3x to the power of 5 minus 2x cubed y. And in place of dy by dx, I'm going to write down that expression we had, which was 3x squared y minus y squared, 3x squared y minus y squared, the whole thing divided by x cubed, right? Yeah, the whole thing divided by x cubed. This is dy by dx. And then on this term, we've got minus 3x to the power of 4y plus 3x squared y squared. And this denominator, do not forget it, okay? All right, now the first term, that x cubed can be cancelled, all right? So that denominator, x cubed can cancel from these two terms here, which will then simplify this term. X cubed cancels. This would be 3x squared minus 2y. Okay, just that. And then we can multiply with the numerator. That's 3x squared y minus y squared. So what I've done is that I just canceled the denominator with these two terms, giving 3x squared minus 2y. That's good. And then we've got here 3x to the power of 4y plus 3x squared y squared, the whole thing divided by x to the power of 6. As you can see, this is a lot more algebraic, okay? Calculus is over here, all right? Just to know the quotient rule and how to use the implicit form, that's calculus. The rest is algebra, but that goes on to show the importance of algebra in calculus. So you better get to know your algebra well. Do not ignore your algebra if you're in lower classes, okay? Because by the time you come to 11th and 12th, this is what's going to help you. Okay, let's multiply these terms now. So you get 3 and 3 is a 9x to the power of 4 y, and you got a 6x squared y squared, and you got a minus 3x squared y squared plus a 2y cubed. That's from these two brackets. And here we've got 3x to the power of 4y plus 3x squared y squared. So something has to be simplified further. 9, yeah, that term, this term and this term will give you 6, right? So that's going to be 6x to the power of 4y. Negative 6 and, yeah, negative 6 and negative 3 is negative 9. Basically, these two terms can be knocked off. Yeah, so that's just reducing to negative 6. So this is going to be minus 6x squared y squared. And then you've got, took care of this term, and then we just have a 2y cubed. And that whole thing divided by x to the power of 6. This should be your d2y over dx squared. Okay, so as you saw, that is how you find the first and the second derivative of a relation where y is defined implicitly. This is the process of implicit differentiation, but we are finding the first and the second derivative, and there is some product rule used here. There's a quotient rule also happening. Okay, and after you found the first derivative, be very careful with the algebra. This example shows you the importance of algebra in calculus. Okay, and this was just with x and y. The moment you have something like trig functions and inverse trig functions, you need to know your identities also. Okay, so I didn't want to make it too intensive, otherwise this video is going to get very long. But we are going to have a live session one day very soon where we are going to solve all kinds of questions on techniques of differentiation. It's going to be a live stream on YouTube, and hopefully you can join us for that live stream when we are going to do all kinds of questions on techniques of differentiation. If you found this video useful, please make sure that you like, share and subscribe to this channel. I'm going to see you all in the next video.